push that rock here with Simpson math. Let's talk adding fractions. So what we want to do is we want to add two fractions like these two. So we want to take something like 1 over x plus 1 and add it to x over x plus 4. These are algebraic fractions and we want to be able to add them together. But I want to back up, understand the process. So we're going to back up all the way to grade school. So here I have half of a pizza colored, and then I have the same size pizza, a third of it colored, and we want to add a half of a pizza. I have a half, you have a third, we're going to put it together. How much do we have total? So we want to add a half to a third. And what students tend to do is just add straight across, because you multiply straight across. If we were multiplying, we would go 1 times 1 and get 1, and then we'd go 2 times 3 and get 6, and we'd get 1/6 because a half of a third is a sixth. But we're not multiplying here, we're adding. And if we're adding, then if we were to add straight across, we get nonsense. So look what happens if you add straight across. If you go 1 plus 1, you get 2 in the numerator. And then 2 plus 3 would be 5. And so we're saying that if I have a half and I add a third to it, I end up with 2 over 5, but 2 over 5 is 2/5, which is less than a half. So I started with a half, I added a positive amount, I added a third to it, and somehow I got less than a half. That doesn't make any sense at all. So you don't just add straight across. That doesn't make sense, and math makes sense. So what do? Well, you determine a common denominator so that you're talking about the same sizes of parts of the pizza so that you can put it together. So in this case, we divide the pizza into 6. We make this 3/6. So we divide this into thirds. So now we have 1, 2, 3, 4, 5, 6, 6, but we've got 3/6 is a half. Then over here, oh, what's this? I don't know what that is. I don't know how to make it go away either. And so, Acrobat, you're really irritating me. Okay, we'll just move. And so, okay, good. You can see this and try to ignore the ad. I don't know if I click on it. Oh, there we go. There's the next. Oh, thank gosh. Okay. All right, so anyway, we got a third here. I'm gonna do the same thing. I'm gonna divide all the thirds in half so that we have 6/6, but I've colored 2 of them, so 1/3 is the same as 2/6. So we know that a half is the same as 3/6. Now the way you do this without just visualizing it is you multiply the top and the bottom by the same number. So 3 times 1 is 3 and 3 times 2 is 6. And the same thing over here, I'm going to multiply the top and the bottom by the same number. 2 times 1 is 2 and 2 times 3 is 6. When you multiply by the same number in the numerator and the denominator, you're multiplying by 1, and if you multiply a number by 1, it doesn't change it. And so that's why this is allowed. And so I have 3/6 plus 2/6, I add it together, that means I have 5/6. And that makes more sense. If I have a half of a pizza and I add a third in, I should have almost the whole of a pizza, so 5/6 makes sense. So that's what you do. You have to get a common denominator, then you add those sizes up. So the denominator stays the same, because you're adding 3 of this size and 2 of this size, so you get 5 of that size. So the denominators are just telling you what size you're adding, and the numerators are telling you how many, so you only add the numerators. And that's how adding fractions makes sense. So now we're gonna come back over here to our algebra problem, and we're gonna try to add these two fractions. I guess I need to blow that up. Let's move it over and make it a slightly, oh, it won't let me move it for some reason. So we'll just blow it up so you can see it better. Okay. Well, between the ad interrupting and me not being able to use the board, this video's pretty bad. Okay, we're gonna get a common denominator. So we're gonna multiply by the same thing in the numerator as we do in the top, so that we're multiplying by 1. So this fraction, we will multiply in the top and the bottom by x plus 4. Why x plus 4? Well, if I multiply this denominator by x plus 1 by x plus 4, I'll have that pair of binomials as the denominator. So I can come over here and multiply this one by x plus 1 over x plus 1, and I'll have the same pair of binomials in the denominator, so the denominator will be exactly the same. So over here, I'm going to come over and multiply the top and the bottom by x plus 1. So this pair of binomials is exactly the same as this pair of binomials, and so I have the same denominator. Since I have the same denominator, I can add them up. But let's simplify our numerators first. 1 times x plus 4 is just x plus 4. And it's over this common denominator, x plus 4 times x plus 1. And over here, x times x plus 1, well, you have to distribute. So I get x squared plus x over x plus 4 times x plus 1. So I now have a pair of fractions with the same denominator. Remember, the denominator is just telling you sizes, so I'm going to end up with the same size fraction. So it's going to have the same denominator. But how many of those are going to have? The numerator tells how many. So I add just the numerators. And so I add like terms. X plus x is 2x. X squared has nothing to add to it, so it's x squared. The x plus x is 2x. And then I have the plus 4. And now I could try to reduce by factoring and reducing, but this one is not going to reduce, so I'm safe. How do I know that? Well, I can look at this and see it's not factoring. See my video on factoring trinomials. Math made simple, Simpson math.